So what do we have over here? We have an object thrown straight down with an initial speed of 4 meters per second from this height. Okay, so just to draw this out, maybe it looks something like this. That's not a straight line. Here we go. This is 8 meters above the ground, and we have this chap over here who decides that throwing an object straight down at 4 meters per second is a wise idea. So let's just illustrate that. So he's got this object over here. It's going down 4 meters per second. Now the thing is, we're going to treat our upward direction as positive. So what does this mean over here? It means that this initial velocity, this initial speed, this initial velocity, stand corrected, so u value is equal to negative 4 meters per second, just because we're treating upward as positive. So the speed here is just telling you the size of this velocity, but the negative here tells you that it's going downward. Now, let's see what else we got. So what is the time taken for this object to hit the ground? So assuming that we're starting from over here. So let's see. Okay, maybe I shouldn't have drawn this green part over here initially. So I'm just going to rub that out. So just, there we go. Okay, just rub that out. Okay, now assuming that it starts 8 meters above the ground, it's going down at 4 meters per second, then we want to find just time taken to hit the ground. Now, a few things we can put in over here. So one thing to say is that we're on Earth. So this means that our acceleration is going to be the gravitational acceleration, which is negative 9.8 meters per second squared. So negative because gravity acts downward. X is going to be, well, I mean, we do need to displace by 8 meters, but is it 8 going up or 8 going down? We want this object to be going down 8 meters. So this means that this X is going to be negative 8 meters. Now U value, well, we established that before. This is negative 4 meters per second. And what we want to know is, what's our V? Actually, sorry. First part of the question says, we want to find the time taken. We also want to know the final speed afterwards as well. So these are the two things. So from our constant acceleration formula over here, we can work out which one to use. So first of all, let's find out something that correlates t, a, x, and u. So over here, let's have a look. Looks like this one over here can be used. So it has x, u, t, a, and t. So when we combine all of these together, let's see what we get. So we have negative 8, so this is our x, is equal to ut. Now we have negative 4, we don't know what the value of t is. And we also have plus half a, so this is negative 9.8, t squared. Oh boy, we've got a quadratic over here. So let's get excited. Alright, now we've got a quadratic, then let's use a bit of our algebra skills here. So you want to solve a quadratic. Make one side equal to 0. So I'm just going to say I'm going to make positive 8 on the right, minus 40. I'm just going to work with a fraction over here. Maybe it'll make our lives easier. Say that. Actually, just for simplicity of this problem, just because I don't have a CAS on me, I'm just going to say this is negative 10. So I'm going to change my accelerations to just negative 10. So you can work with negative 9.8. It's just that, just for the sake of showing you the methodology, I'll just use negative 10 over here. There you go. Half times negative 10. So this is going to give you negative 5t squared. Now if you want to solve a quadratic, then a couple of things you can do. but I'm just going to use quadratic formula here because that's probably the fastest way in this case. So t is going to equal to, let's see, now at the top we have, actually, for those of you who forgot what quadratic formula is, let's just quickly recap what that is. So this is x is equal to negative b plus or minus b squared minus 4ac over 2a. Okay, so the b value is negative 4 here. So we're going to get positive 4 plus or minus the square root of b squared. So negative 4 squared is 16 minus 4 times a is negative 5, c is 8. So that's our constant. All this is divided by 2a, so 2 times negative 5. Just going down a little bit. Here we go. So we get 4 plus or minus, what's inside the square root? We have 16 plus 20 times 8. So that would be, so 20 times 8 is 160, so we have 176 over negative 10. Alright, let's see what this gives us. So this should give us two solutions. So we'll consider the positive case first. What happens if we say that we're taking the plus sign over here? Okay, so this is for the positive case. See what we get. So we have 4. Actually, we'll start with the square root, just because we're on this calculator over here. So the square root of 176, that's about 13. And we want to add this to 4. Then divide by negative 10. Okay, so this gives us about negative 1.72. Okay. Fair enough. Say 7.3, just round it up. Okay. Or, what else can we have? What if we're subtracting by the square root of 176? What would happen then? So, in this case over here, we're going to have, what will it be? 4 minus the square root of 176. So 4 minus 176 square rooted. Is that right? Yep, so negative 9.3 divided by 10 give us about negative 0.93. Actually, what was that? That should be positive. Okay, so 0.93, because I divided by positive 10 before, so divided by negative 10 means it'll be positive 0.93. So remember that what we're working out over here is time. Okay, so this was the negative case, but however, if you subtract by this third over here, you get a positive value of time. So this is what we want, and we don't want this over here because this is a negative time value. We're not going to deal with negative time in this physics course, so we're just going to ignore that over there. So we can say it takes about 0.93 seconds if we take gravity as negative 10 meters per second squared. And we can also find the velocity, the final velocity. So over here we need to correlate v, u, x, and a. Now if you do that, we can use this equation over here, equation 5. Okay, so let's just jot that down. So we have v squared equal to u squared minus 2ax. That was plus. Was it? Yes, that was plus. Okay. And all of our variables, we have a as, or just make it negative 10 again. Doesn't really matter. -8 for x, and -4 for u. So plugging all of that in, what do we get? So v squared is equal to, now u over here is -4 squared out plus 2 times -10, and our displacement has to be -8. So if we evaluate all of this, we get 16 plus, let's see, so we get 80 over here times 2, that is 160. So 176. Of course, this isn't our final velocity, this is just the final velocity squared. So we need to square root this number. I believe this gave us about 13, but we'll just double check. It's 176 square rooted. Yes, it does. So that means we get about 13.27. Okay. And that's that.